Example 3, a couple things happen on this one that haven't happened yet. First thing is, notice x squared plus 4x plus 3 is a quadratic trinomial that happens to be factorable. All right? If I see anything factorable, I want to factor it first, if possible. This is just using the factoring technique we saw the other day. 3 times 1 makes 3, 3 plus 1 makes 4, so 3 and 1 are the magic numbers that go with x to factor that. So x plus 1 and x plus 3. Okay, if we take a look at the factors in this problem, we have x plus 1, we have x plus 3, we have x, and notice we have x plus 1 again. This x plus 1 and that x plus 1 are exactly the same x plus 1. So when we go for the least common denominator here, LCD equals, and I write every different type of factor that occurs, x occurs, x plus 1 occurs, and x plus 3 occurs. I'm not going to write x plus 1 twice. I'm only going to write it once. And I take the highest power that occurs. This is x plus 1 to the first, x plus 1 to the first. The highest power is the first. So x plus 1 has to be written down one time, even though it happens multiple times. This is a frequent occurrence. If you do not factor this, you're going to get me some ridiculously large answer that I don't want to grade and you don't want to do. All right? So every year I have at least one student that does this. They just go with that as the common denominator. This times this times this. They get this big, huge monstrosity of an answer that's right. It took them 15 minutes to do it. I got to rework the problem myself to see if it's right. It takes me about 3 minutes to grade it. And neither one of us wants to do that. So don't be that person this year. I usually have to sit down with them afterwards and discuss listening better in class. But anyway. Factor trinomials, they will be factorable. Typically when you have a factorable problem, you're going to have a common factor like this occurring to create a nicer least common denominator as opposed to, let's say, doing numbers, the common denominator is 12, but you got 36. That's kind of the difference of what's happening. You're creating a bigger common denominator. It still works, it's still legal, but it just makes the problem more difficult than it has to be. So, least common denominator is this thing. So I would write down then, just like before, big fraction bar. Notice this fraction bar is getting longer because I'm kind of anticipating this is going to be a little bit bigger answer. X times x plus 1 times x plus 3. I'd like to put monomial pieces in front of binomials. So, I mean, looking at the order of things, it's this, this, and this. But I like to put that x in front. Just, I think they look a little friendlier up there. So just I tend to put those in front. It doesn't matter what order you put those things in the bottom. All right, first fraction is this. And the numerator of the first fraction is x plus 2. And the denominator was x plus 1 times x plus 3, which is here. This x is not part of the original denominator, so the x is new. So times x for the first one. The second fraction is minus 1, so I write minus 1. Again, I'm trying to make sure that I'm putting enough emphasis on this. There has to be a plus or minus sign here, and it has to match whatever was in the original problem every time. Okay. The original problem had x times x plus 1 as the denominator. Now it's got x plus 3 extras, so x plus 3 goes here. This was nearly as bad as I thought it was going to be. Alright. The really, really ugly one's coming up the road a bit. Okay. Because I know they happen sometimes where you get all these things. It's just this. I had to start writing tiny over here in the corner so it fits. Kind of crazy. Alright. So what's left to do then is the distributive property here. So x times x plus 2 and negative 1 times x plus 3. And again, the thing to be careful about here with the distributive property, when the minus is in front, that minus is distributing with the multiplication. So over on the left-hand side, the black ones, x plus 2 times x is going to be x squared plus 2x. And for the green ones, negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. And again, this is a frequently missed sign here, so be cautious that you're paying close attention to detail in your work. X times x plus 1 times x plus 3. Again, the denominator keeps moving along. Nothing happens to the denominator once you create it. Like terms happening right here. So x squared is fine. 2x minus x is equal to positive 1x, and then minus 3 all over x times x plus 1 times x plus 3. All right, so that's probably as challenging a problem as you're going to get right now. But again, shortly we're going to revisit this topic, and they're going to be uglier. Basically, the top keeps on getting bigger. The bottom kind of is, that's how the bottom looks like every time. Okay, so the top tends to get bigger. That's what makes these more and more challenging as we go along.